Good evening and welcome to Tinkering with Edkelar. In this episode I'm finally finishing up with the ES500 scope. Let's see if it works and also have a quick rundown of the features. So without further ado, let's dig in! What might be called the neck board is next. The CRT socket and assorted components. That breakout board in the back also gets new banana sockets. Some people might object that I had only the bare metal ones around, but please, right next to them is the bare metal terminal for the deflection voltage. The phone output has a 1 meg resistor between that at least. The cloth wire might be stylish, but it is a solid core wire with a lacquer insulation. To solder it, you're supposed to use a hot iron. Now, I tried literally until the tip of my solder gun was glowing. That lacquer doesn't melt or burn. To make my life easier, I got a mini Dremel and sanding drum. That works. Sand away as much of the lacquer as possible, then tin the wire and solder it like any other. And here comes the big moment. After over a year, I can finally put in the CRT and see if it works. Yes, I see a dot. Intensity and focus do their job and I can move it vertically, but horizontally, it is stuck on the left edge. I was worried that the tube might have a broken connection to one of the plates, but it turns out that the horizontal centering potentiometer was having a bad day. I opened it up again and fixed the contact issue. Now I can move the dot around all over the screen. Now that I can move the dot on the screen, I can finally align the tube. It doesn't have a beam rotate control, so that's a mechanical adjustment in the socket. I move the dot to the left, right, top and bottom and mark it with a dry erase marker. Then I can use a ruler to align it with the case. Next, I'm running the heater voltages across the tubes. There's the phasing control connected to those as well, so it's important to keep track of which line ends up where. The first tube I'm connecting is the VR150 regulator, so I can get the secondary B+ for the vertical amplifier. Next, I connect up the 6J5 input tube. It is used as a buffer only, so the output is the same as the input, but it keeps the input impedance high. A quick check with my regular scope confirms. Output equals input. The input signal is put through a 6AK5 tube next, which ups the signal considerably, but also flips it around. Here's where the circuit also has a revision. The original used a coil in series with the output signal. The new design has a trimmer capacitor in parallel and uses it in the supply line. I'm not sure what this is supposed to be doing. Looks like a notch blocking filter at a glance. Maybe to avoid some oscillation. The third tube in the input section is the driver for the deflection plates. It runs against the full B+, and part of the signal is fed back into the sync circuit. Now the test gets a bit more linear. Yes, I got a line. The input attenuator is either a direct link or a divide by 10 or 100 divider. It also has compensation capacitors to fine-tune the level. I fed in a signal and made sure that the output is 1/10 and 1/100 of the input. Now to the more convoluted part of the circuit, the horizontal deflection. I really need to do some proper AC experiments, cause I can only assume the function of this part. Generally speaking, the source is either the line voltage, making the X deflection a sine wave. This could be useful to detect phase shifts in supply circuits. The next position is external input to drive the X-axis from an external connection. And then we have 4 different ranges for a sawtooth wave that is generated in the 6SN7 tube. The actual frequency of the sawtooth is controlled with the vernier control. The horizontal amplifier tube is the last bit. Simple enough. And again, after all is connected, I check the sawtooth and it looks a bit dull. Might need some sharpening, but at least it's within the expected frequency. And here's the big moment. Yes, it works! But for some reason the sawtooth is anything but. I mean, it's okay for such a device to not deliver a perfect ramp, but the manual prides itself in the linearity of it, so I'd expect a bit better than this. Especially since the upper range is very linear indeed. Also, only a fraction of the amplitude. What gives? After a bit of hunting and validating connections, I found a bad ground connection in the range switch. Whoops! Now it works. Even the lowest range now has a nice linear ramp. And to keep with the original style, tying up the wiring loom. I'm not quite sure if the guide I found was proper. Also, I found contradicting instructions. So I'll just wing it. Now that everything seems to work, I put it to the test. But during these tests I saw a weird twitching in the Y deflection. It took ages to narrow down the problem. Which lies just here. Now the first two stages of the Y amplifier are powered via the 150 volt regulator tube as a secondary B+. It is connected to the main B+ via this 20 kilo ohm resistor, but for some reason it seems to glitch out ever so often. It would drop by a few volts and then go back to normal again, over about half a second. The coupling caps would see that as a negative and positive spike, which led to the twitching. The fix was to put a resistor in parallel. I used 390K and thus slightly increasing the current for the tube, and ta-da! Stable 150 volts. Let's have a quick rundown of the features compared with modern scopes. The input frequency range is given as 10 Hz to 1 MHz, but the built-in sweep only goes up to 30 kHz, so I'd say 100 kHz is about the highest frequency that you can show well without any external help. The X input supports up to 500 kHz, which would put the 1 MHz within range. The input is AC coupled, no alternative. The circuit isn't geared for any DC offset voltages at all. The synchronization control is tweaking the start of the sweep oscillator, so it can be seen a bit like a trigger, but if it is set wrong, the sweep will repeat multiple times and cause a weird flicker. Both the X and Y axis have gain controls with no calibrated positions. It is thus not possible to read voltage level or frequency from the graph at all. The main use seems to be for audio range. A giveaway is the headphone hookup in the rear. It provides a tap into the Y deflection so you can listen into the signal on display. The scope has an input for external sync, similar to a trigger input, and a beam modifier, which is similar to a Z input for controlling the intensity. Both of these are not amplified, so you need to have the correct input levels to work. For some reason, there's also a 6-volt output. That is one of the heater windings, unfused, right next to the ground lug. At least the manual states, do not short. The phasing control adjusts the phase between ± 90 degrees for the line sweep setting. To show that, let's connect the 6-volt output to the input and select line sweep mode. And that's it! A restoration or maybe even rebuild of a Precision Instruments ES500 scope. I hope you enjoyed the process and the result. Oh, and did you notice that weird noise in the last episode? I finally got a recording from it. Let's have a peek, maybe the waveform can tell something. Nope, doesn't look like anything useful. Too bad this isn't a dual trace scope, so I can look at left and right. Oh! Let's connect it in XY mode. Well, I'll be walking 500 Hz and 500 more apparently. And that wraps up this project. See you next time!